Do 4 and 5 real quick. We're going to finish up 2.3. Go to the quiz prep right now. But we'll finish 2.3. Going 2 problems right now. Then we're going to do 2.4.2.5. Now 2.4.2.5 is basically one type of question: solving quadratic equation. There's multiple methods in 2.4, and then it just carries on to other examples in 2.5. Next Monday, we complete 2.4.2.5. We do that first. Then, when we're done with it, we go over more questions that you have on the quiz prep 2.1 to 2.3. At 11:20, the quiz begins. 11:20 to 11:50. That'll be the quiz. I'm going to give you a half hour because there's going to be, quite a few bonus questions. You see some that are lit up right there as bonus level. You also get the review sheet on Monday. On Wednesday, we review. The following Monday on the 4th, we take the test and the homework bit. Okay. I haven't written up the quiz yet as to how many questions there are going to be, but it would not include anything different than what you're seeing here on this quiz prep. If you look right here, this is 2.1 to 2.2. This is number 1, 2, and 3 are from 2.1 to 2.2, solving an equation. And then this is 2.3, anything we're dealing with an I. So 4 through 7 would be 2.3. And then you have your bonus examples. And then the bonus examples from the other quiz prep. Number 4. Number 1. For 85 plus 8 square root 245. We have minus, and I think I'm just missing. I don't know why sometimes it doesn't come out correct. It's missing the parentheses. So it didn't copy over correctly. Minus negative 91 minus 8 square root negative 108. And then number 5 is multiplication. Number 5 is 5 square root 4 minus 5 square root negative 4 times 2 square root 100 plus 3 square root negative 49. Okay. Order of operations. You should always simplify first. Order of operations. In this parentheses, 85 is simplified, plus, now when we simplify the radical, this 8, remember we used the analogy of breaking out of jail? 8 is the getaway point, and it's waiting to see what's going to break out of square root negative 245. First thing you want to do is focus on the fact that it's negative. So when you have a negative in there, you're going to poke out the I. Now, don't worry about the negative. The I is out. Simplify the 245. Square root, we need two of a kind. So I just need two numbers that multiply together when break it apart that make 245. If it ends on a 5, it'll just go 5 times 49. 5 times 49 is 245. So this would be a 5 times a 49. And then this is, because I don't have a pair yet, 5 times 7 times 7. Sometimes branches can grow up. Factory. So a pair of 7s make a run for it. Only one 7 makes it out. So 7i broke out of square root negative 245. This 5 doesn't have a pair to break out with, goes back in square root j. So the square root of negative 245 is 7i square root 5. So it's this still, and we're going to subtract and leave it as a subtraction problem until you simplify what's in here. Minus, inside we still have negative 91. Negative 8 is the getaway car, negative 8 times, waiting to see what breaks out of negative square root 180. There's an I, so poke out the I. Square root of the negative, poke out the I. And then factor 180. So it ends in a 0, so I can use a 10. So this is 10 times 18. 10 times 18, so that's a 5 times a 2. And that's a 2 times a 9. So there's a 5 times a 2 times a 2. 9 is 3 times a 3. So here's what broke out. A 2 broke out, a 3 broke out, so 2 times 3. And then there's a 5 back in square root j. But here's what we have. 85 plus 8 times 7 is 56i square root 5. Now, I'm not ready to distribute this negative yet. So minus still negative 91. I'm not going to distribute the negative until I simplify what's inside. Negative 91 minus 8 times 2 times 3. This is 6. 8 times 6, so minus 48 I square root 5. 85 plus 56 I square root 5. And again, notice I'm working the problem from left to right and then bringing the next step right underneath all the way across. So I don't miss anything and I don't forget what the signs are. Got to keep track of everything. Minus a negative 91 becomes plus 91. Minus a negative 48 becomes plus 48i square root 5. Now we can add the like terms. 85 and a positive 91 is 176. This is a 56 I square root 5. So I'm looking for another I square root 5. But yep, this is an I square root 5. So these are like radicals. These are like terms. So I have 56 of these I square root 5s, and then 48 of those I square root 5s. So that is 104 of those I square root 5s. I have told you, I implore you, I am asking you, I'm telling you right now, please put I in front of the radical. It is not wrong if you put this if you put it after the radical. That's how the answers are written in the back of the book. And if all you do is copy the answers from the back of the book, you may never know the difference, so you'll keep on doing it that way. If all you're doing is using a calculator to get to the answer, you're going to write it that way. But you know what you're going to write? It's going to look like the I is in the square root. That's wrong. And I will take off, I will not be merciful. I will take out points like nobody's business because it's wrong. I told you, please put it in front. And I also know, hey, they're not, if they're getting the answer from somewhere else, it's a dead giveaway. Okay, so that's what's going on there. Simplify, combine like terms. What kind of question was this one? Subtraction or addition. Parentheses, and then add or subtract the answers, or add or subtract the like terms. Versus number 5. Number 5, you're multiplying. This one, we're adding and subtracting right here. Addition or subtraction. You know what I'll see people do? Multiply it out because I see parentheses. I see, rainbows, arrows going all over the place. And it's not what the question is asking. Simplify, add or subtract. Will I remind you of this on the day of the test? Yeah. Will people still multiply it out? Yeah. That's why I have no head. I have a Homer Simpson head. Okay. Simplify first. Don't multiply this out until you've simplified what's inside. This is just getaway car is 5. What's the square root of 4? So 5 times 2 minus getaway car is 5. What's the square root of -4? 2 times I. And this is 2 times what's the square root of 100? 10 plus 3 times what's the square root of -49? 7i. Those are nice, perfect squares. And they simplify really nice. So we end up having 10 minus 10i times 20 plus 21i. Which is a lot nicer to multiply together than 5 squared root of 4 minus 5 squared root of -4. Simplify first. Simplify first. Order of operations. Do what's in the parentheses if there's anything you can do. So now we distribute. We get 10 times 20. I'm going to write this up. 10 times the 20. And then a positive times positive. Positive is going to be a positive. We get 10 times 21i. And then we have a negative times a positive, so that's going to be a negative. 10i times 20. And then we have a negative times a positive, so that's going to be a negative. 10i times 21i. This last times last, when you're dealing with imaginary numbers, this last times last is going to be a little tricky. A negative times positive is a negative. 10i times 21i. So you got to be careful there. 10 times 20 is 200. Plus 10 times 21i is 210i. Minus 10i times 20 is 200i. Minus 10 times 21 is 210. I times I is I squared. That's what gets forgotten. I times I right there is going to be an I squared. Now, what I hope you do is go from blue to black right here. And you don't need to write out the 10 times 20 plus 10 times 21. If you do, that's fine. But be clean, be organized about it, right underneath. Straight across, so everything is accounted for. Practice it that way. So we're not ready to do a whole lot except we have a 200. There's no other, there's no other, everybody else has eyes. So there's nothing I can combine with the 200 yet. Here's I to the first and an I to the first. 210 I to the first, take away 200 I to the first. 210, take away 200 I is going to be a positive 10 I. And then watch what happens here. What is I squared? I to the first is just I squared is I to the third is I to the fourth is what? -1 was I to the first. Negative I to the fourth, and then it repeats. So this is negative 210. I to the second is -1, so it's negative 210 times -1. This becomes positive 210. So now you have two like terms. 200 plus 210 is 410 plus 10I. Okay. We went through 42, but I'm going to go back and do 31 and 38. And 44. Okay. Let me simplify. Radical. And anytime you can simplify radicals. You want to simplify the radical first before you actually multiply, before you do any kind of operation. You want to simplify the radical. And in this case, because there are negatives here, you're going to poke out the I. So we're going to poke out the I. The square root of 6 does not simplify because square root of 6 is just like 2 times 3. Nothing is breaking out of square root of 6. So it's I times the square root of 6 times, poke out the I. This is I square root 2. Now the rules of multiplication. for any kind of root. For any kind of root. The nth root of A times B can be separated into the product of each factor. The nth root of A times the nth root of B. But equals works in both directions. If I have the same radical of A times same radical of B, I can make it one radical. So I can multiply it. If you look at this, I can rearrange this if you need to see it. This is I times square root 6 times square root 2. So I get I squared, and then I get square root of 6 times 2. So I'm looking at I squared right now times square root 12. You don't have to show all of this in the middle. The coefficient I times I squared. Square root 6 times square root 2, you multiply the inside, we get square root 12. You don't have to show all the little pieces of rearranging it. But the fact that we can rearrange it is why we get I squared times the square root of 12. There's a reason why. What's I squared? Negative 1. We have to poke out the I first. Now, if I can simplify the radical, we need to do it. You know, factor trees can go down, they can go up, you can even go sideways. What makes 12? We can do 2 times 6, we can do 4 times 3. What do you want to do? So 2 times 6, which is 2 times 2 times 3. So a 2 will escape, and there's a 3 still in jail. So negative 1 times 2 squared 3, negative 2 squared 3. So the square root of negative 6 times the square root of negative 2 is equal to the negative 2 square root of 3 when you simplify. But we don't get there unless you simplify everything you can do first, which means all I can do is poke out the I. Now I multiply what's inside and then simplify. But you poke out the I first. Simplify before you multiply. On 38, we're just distributing, boil it out. First term times first term, 6 times 2 is 12. And then get your signs right. Positive times a negative, that's a negative. 6 times 3i is 18i. And then you distribute the second term. It's a negative 2i. Negative 2i times positive 2. So it's going to be a negative 4i. And then always get your sign right. Negative times a negative, this will be a positive. 2i times 3i. 2 times 3 is 6. I times I is I squared. This last term seems to catch a lot of people. They forget to put the I squared. Or they try to do one extra step at the same time. So be careful with that last step. This is 12. These are two like terms. What's negative 18i minus 4i? Negative 22i. And then this is positive 6. What's I squared? So positive 6 times negative 1 is now minus 6 down here. So I have just a little bit more to do. I can combine 12 and minus 6. 12 minus 6, 6 minus 22, 5. Yeah, a term minus something and it's a perfect square. It technically is like a minus b perfect square, which is square the first one minus multiply these two together, but you double it minus 2ab, and then you square the last one. But it's going to be a little tricky to try to do it with this. You got to keep track of everything. It would be 9 minus 40i. Now, I rarely get them right when I try to do them in my head. I always mess up the sign of the last term. So I don't recommend doing it this way with imaginary numbers, complex numbers. What just happened is this. You have a squared minus 2ab plus b squared. So a is 5. So I square the 5. And then minus 2 times a is a 5. And b is a 4i. And then plus b, which is 4i, squared. So I got 25 minus 2 times 5 is 10. 10 times 4 is 40 minus 40i. And then this became 4 squared is plus 16 times I squared. Since I squared is negative 1, 16 times negative 1, it becomes minus 16. 25 minus the 16 gives me the 9. But I always mess that up when I do it in my head. I don't know why I'm getting it right today. Maybe my age factor and my early onset kind of clouded mind is actually working. It's actually doing the reversal of what I was doing. So just do this. 5 minus 4i minus 5 minus 4i. It works out better. 5 times 5, 5. 5 times negative 4, negative 20. Negative 4i times 5, negative 29. Negative 4i times negative 4i, negative times negative, positive. 4i times 4i, 16i squared. But negative 20i, another negative 20i, that adds up to negative 40. Positive 16 times I squared, which is negative 1, so minus 16. 25, take away the 16 with out. I don't have to know the special product rules to get it right. I just need to remember it's not just square root each one and hope it, hope it. Follow it out. Okay. On 48, there's special instructions. Input by the radical. What does that mean? Things you have to do to make sure the radical is simple. Like a little checklist. No perfect and powers left inside of an nth root. No perfect squares left in the square root. No perfect cubes left in the cube root. No perfect fourth powers left in the fourth root, so on. If they can break out of jail, you got to break them out. Poke out the eye if it's negative. Simplify the radical. Okay? The next rule. No fractions in a radical. You can't have a fraction inside of a radical. Any kind of radical. Nth root, square root, cube root, fourth root, any kind of radical. So we have a problem. We have a method for this. I have the square root of 1/2 on the inside. The rule for a fraction. We have product rule. For a fraction, the nth root of A over B is just the nth root of A over the nth root of B. You can split it up. So I can rewrite this as the square root of 1 over the square root of 2. What's the square root of 1? 1, thank you. And then square root of 2 is not a perfect square. It doesn't simplify. 1 over square root of 2. But the problem is that violates the third rule. No radicals left in the denominator. There's a technique you need to learn how to do. Square root of 2 is an irrational number. So what you have to learn how to do is rationalize the denominator. Right now, it's an irrational number. We have to rationalize. No radicals in the denominator. It's a square root. How many of a kind do you need to break out of a square root? We need 2 of a kind. We have 1, 2, so we need another 2. So I'm going to multiply by another 2. I'm going to multiply by square root 2. Gives me 2 2's. But if I just do the denominator by square root 2, I'm changing the problem. So what I have to do is also multiply the numerator by square root 2. If I do both of them by square root 2, numerator and denominator, what am I actually multiplying by? What's square root 2 over square root 2? 1. So I'm not changing anything. What I'm changing is what it's going to look like. What I'm doing is I'm simplifying the radical. I'm following how to clean it up. This is 1 times square root 2. Down here, square root 2 times square root 2 is, let's look at this 2 ways. Actually, 3 ways. Square root 2 times square root 2. If I have 2 radicals multiplied together, I can multiply the insides as they're under 1 radical. So this would be square root of 2 times 2, which is the square root of 4, which is what? 2. Or I have square root 2 times itself, so it's the square root of 2 squared. What's a square going to do to the square root? It's going to undo that square root, so I just get the 2. That's the whole purpose. Or technically, when I multiply square root 2 times square root 2, I'm going to get the square root, and on the inside, 2 squared. The square root undoes the square, and I just get 2. The whole purpose is to get rid of the radical down there. So if I take a square root and multiply by itself, times itself, it undoes the radical you're just going to get to. So you have to show this work? No. The whole purpose is knowing that this times this is just 2. You don't have to you don't show this. You do have to show how you got here. There's my answer. The radical inside is simplified, square root 2, nothing breaks out. There's no fraction in the radical, and there's no radical in the denominator. If you have I, so this is where number 31 comes in. So not 31. It's actually going to be 55. 48. I'm going to do 55 and come back to 48. 48 times into 50. Sorry. I'm quoting wrong. I'm going to do 56. And then 48 will help with you. 56. 6 is just negative 5 over 2i. We're supposed to simplify. Well, negative 5 over 2i, nothing simplifies. 5 over 2 reduced. The problem is, I is a square root negative 1. You can't have radicals in the denominator. I is a square root. You can't have I in the denominator. So we have to rationalize it. I squared is the only way to undo an I. I times I squared. So to undo this I need to multiply by another I. So I need to multiply it by I over I to undo this I down here. In the numerator, I have negative 5 times I. In the denominator, I have 2 times I squared. So I have negative 5 times I. What's I squared? Negative 1. So that's 2 times negative 1. So down here I have negative 2. Last thing you need to do, clean it up. What's a negative over a negative? Positive. So this equals positive 5i over 2. So negative 5 over 2i is equal to positive 5i over 2. So you can see the directions regarding number 42. Write the complex conjugate of the complex number. Then multiply the number by its complex conjugate. Okay. Conjugates. Conjugates are just the same thing, change the sign. A plus B times A minus B. A plus B and A minus B are conjugates. exactly the same terms, an A and A, a B and a B. Same exact term. First term is A, first term is A, last term is B, last term is B. The only thing that's different is the plus, one's a minus. Maybe the first one's a minus, second one's a plus, different sign. Because when you multiply two conjugates together, this is a special product. When you multiply this together, you get a difference of two perfect squares every single time. So the complex conjugate, or just the conjugate of 3 plus 5i is 3 minus 5i. Exactly the same term, a 3 and a 5i. So it's 3 minus 5i. If this one's plus, this one's minus. Same two terms, change of sign. That's the conjugate. Now, since they are exactly the same, but opposite sign, when I multiply this together, I'm going to get a squared minus b squared. You have to be really careful about this. If I use the special product, I'm going to get 3 squared. The first term is going to get squared, and then it's going to be minus. I'm going to get the last one, the b squared. So it's going to be parentheses 5i squared. So I'm going to get 3 squared is 9 minus, when I square the 5i parentheses squared, I'm going to square the 5, which is 25, and I got to square the I get I squared. You're not done. This is equal to 9 minus 25. What is I squared? How many times have I asked that question today? What is I squared? Just say a lot. Okay. So now this is 9. What's negative 25 times negative 1? You get plus 25. So this right here equals 34. Which was Fernando Valenzuela's number. That's the way it's. You know, Fernando Valenzuela with ones. You should be ashamed. If you use the special product. If you don't use the special product, just multiply it out. 3 times 3 is 9. Positive 3 times negative 5i is going to be negative 15i. Positive 5i times 3 is positive 15i. Positive 5i times negative 5i. 5 times 5 minus 25. I times I squared. Got a 9. Negative 15i plus 15i. Cancel that, makes it 0. This is negative 25. I squared is negative 1. Negative times a negative, that becomes plus 25. 34. Either way. Conjugates. Because when we do number 58, and you're supposed to simplify 3 over 1 minus I. Which but here's the review sheet. I put this up here just to show you something a little bit later. Look at number 4 here on the review sheet. This is just like number 58, It's actually got a little bit more stuff to it. Write the quotient in standard form. You must show appropriate work to receive credit. 3 plus 2y over 4 minus 8y. So the technique you do on this 58 right here is what you got to be able to do on your test. You can't have I in the denominator. So if all you do is what we just did on number 56, sorry, yeah, 56, to undo the I, if all I do is multiply by I over I, if that's all you do, 3I. Down below, though, it's I times 1 minus I. You have to distribute I times 1. I times negative I is negative I squared. So we get 3I over I. This is minus negative 1, so it becomes plus 1. And you still have an I down below. All you did was, instead of 1 minus I, it's 1 plus I. So multiplying by I is not going to undo the I down there because it's a binomial, 2 terms. In number 56, it was 1 term. I just needed to multiply. When it's 2 terms, you need to use the conjugate. To undo 2 terms, you have to multiply by the conjugate. One more time. You got 2 terms, you need the conjugate. What is the conjugate of 1 minus I? 1 plus I. If I multiply the denominator by 1 plus I, I got to multiply the numerator by 1 plus I. In the numerator, we get 3 times 1 plus 3 times I. In the denominator, multiply it out. We get 1 times 1. We get 1 times positive I. 1 times 1. 1. We get 1 times positive I, so that's plus I. We get negative I times 1, so that's negative I. And we get negative I times positive I, which is negative I squared. Now, 1. These two add up to 0. When we do conjugates, you should always get 0 in the middle. That's why we get a squared minus b squared. 0 in the middle. And then minus, remember what this is. Minus I squared is negative 1. So we end up with 1 plus 1, which is down here a 2. That's the answer. Now, in the back of the book, they say write the answer in standard complex form. Standard notation for a complex number. For a complex number, it's the real term and then plus BI, the imaginary term. So what you want to do is split this into separate fractions. 3 over 2 plus 3i over 2. Then again, I implore you, I beg of you, I hope you don't try to do what you might see in the book. They'll write it as 3 over 2 plus 3 over 2 times I, which is kind of what they want. A plus and then the coefficient times I. But I'll tell you right now, if you write it like this, you're okay. But what I see is this. And that makes I look like it's in the denominator. I have to take off points because I is not allowed in the denominator, nor is the answer going to have an I. That just means you're not paying attention to what you're supposed to be doing. So if you put it in the numerator, that means there's no chance of it actually being in the denominator. That's why you want to play it safe, want to get it right, leave it in there. You're protected. Okay. Yeah. That's 68. We simplify, write it in standard form. We have 4i squared minus 2i to the third. And then with 73-ish, simplify. I to the 8,200, 11. No, let's go with 10. This is 4 times I squared. So what is I squared? So that's 4 times -1. Minus 2 times I to the third. What's I to the third?
Negative I.
Negative I. So this is -4. -2 times negative I is plus 2i. You should never have a power bigger than I to the first. Because your i's will be I to the first is just I. I squared is always going to be a -1. I to the third is equal to negative I to the first. And if you end up with an I to the fourth, it's a positive 1. And then the pattern repeats. So we did something like this on Monday when we introduced the whole thing. I to the 8,210, you take that exponent. Since it repeats a pattern of 4, you take this exponent and you divide by 4. 4 goes into 8, 2 times in the thousands place. So we're left with 210. 4 does not go into 2, so we have 0 in the hundredth place. So now we're in the tens place and we're looking at 21. So 4 would go into 21 from the tens perspective 5 times. So that's 200. And then you subtract, we have 10 left over for the 1 place. How many times can 4 go into 10? 2 times, we get an 8, we subtract, the remainder is 2. It's 2,052 times 4, but you have a remainder of 2. The remainder is your new power. This is going to behave just like I squared, and then I squared -1. Final answer. You divide by 4. The remainder is your new power. The remainder is going to be a 1, a 2, a 3. The remainder would never be 4. Because if the remainder is 4, it should have gone in another time. So to get this, you would have a remainder of 0. And according to, gosh, brain is like, remember something I might have actually spent time telling you about over and over and over again. Something called the rules of exponents. Everything to the 0 power is 1. Even I to the 0 is 1. So the remainder is 0. That's just your I before. Hit 1. Okay. So in 2.1, 2.2, we were solving linear equations. Linear equations, the variable is to the first power. X to the first, or whatever the variable might be. Y to the first, whatever. 2.4 and 2.5, we want to solve quadratic equations. A quadratic equation is x squared. A times x squared plus something times x to the first, and then plus a constant is equal to 0. Here are the many ways that we could solve this. Factoring, extracting square roots, completing the square and quadratic formula, and I did this. Okay, solving quadratic step by step. And I'm going to post this for you. You see that? Is that emphasized enough? Right back. And then step by step, I have the square root method. Completing the square method step by step. The quadratic formula method. Written out in detail step by step. What I expect to see from you, the pieces, the steps I want to see from you. Not just answers. It's all posted. And I refer to it, I put into a little table. On your test, I want to make sure we're clear. I have this done by side. On your test, it is specifically outlined 10 points each. Each problem is 10 points. The first 4 questions, okay? You take a look at the review sheet. The first 4 questions are from 2.3. And then we start solving. If a particular method of solving is specified, be sure to solve it using that method. Otherwise, you will receive no credit for the problem. If no method is specified, you may solve using any algebraic method. Remember, you must show appropriate work to receive credit. Number 5, you have to solve using factoring. If you solve it any other way, 0. You didn't get the right answer, 0. I have to see factoring. Number 6, you have to solve it with completing the square. Number 7, you have to use the quadratic formula. And then number 8, number 9, number 10, number 11, number 12, number 13, number 14. Solve it any way you want. As long as you show the algebraic work. By the way, try factoring. Factoring is the quickest, nicest, simplest way to solve a problem. If it factors, you can be done in about a minute. If it factors, and you know what you're doing. Otherwise, if you always stick to the quadratic formula, it'll take 5 to 10 minutes per problem. Because the quadratic formula is not always set up to go. Okay, and then there's more stuff. And we'll be more specific about that when we get to. And there's lots of bonus. Lots and lots of bonus. So again, opportunity is not. You want to know, can you still have? Do I need to do? Lots of opportunity. Okay. It's all based on example. Right, quadratic. So number 5 through 7. Starting with number 7, you guys are. Write the quadratic equation in general form. Do not solve. In general form just means make it equal to 0. Everything on one side, 0 by itself on the other side. Do you like fractions? So if I'm doing number 7, you see how the 1/5 has not been distributed yet? So if I multiply by 5 right now, then that reduces, and I have 3x squared minus 10 equals 60x. And if I'm going to put it in this general form, I just subtract 60x. So let me put this over here. Ax squared plus bx plus c equals 0. And what I have right now is this. It looks like it's 3x squared minus 10 over there is 0. And what I did is I'm subtracting 60x from both sides. Does it matter where I put the 60x? On the left-hand side, does it matter where I put the negative 60x? So I want to make this work. You put it in the middle. X squared should be your leading term, your first term, x squared. Then the powers decrease from x squared, x to the first, and then the constant. Your order is going to matter. Your order is going to matter. So it should be your x squared term, 3x squared. It's a negative 60x, and then you have a negative 10 equals 0 on that side. That's all they want you to do, is to write it in standard form. You're not supposed to solve it. Okay. Right, we're doing 10, we're solving by factors. 16. If you struggle with factoring, we did factoring this morning in the co-rec. X squared minus x. $16. 2x squared equals 19x plus 33. $26 is the negative. When you solve by factor, step number 1, simplify. You can simplify stuff, simplify. Always try to undo fractions. We've already talked about that. You need to If it's not ready for you, you need to rewrite in standard form. Which means make one side 0. And it's ready to go. It's in standard form. Now, there is no constant. We don't have a plus c. We have an x squared, we have an x to the first, but that's it. That's fine. Step 2. You're going to factor completely. You have to factor completely. The first step of factoring from this morning, you factor out the greatest common factor. So you focus on the 9 and the 21. What common factor does 9 and 21 have? 3. They're both divisible by 3. That's the biggest number that goes into 9 and 21. So I'm going to factor out of each one 3. Do they have any variable in common? Can I take out an x of them? I can take an x squared out of this one, but does this have an x squared to take out? No. I can take an x to the first out of this one. Can I take an x to the first out of this one? Yeah. This one has an x to the first thing. I can take an x to the first. They have an x to the first in common. So I can factor out a 3x. Here's what factoring means. It reverses the distribution that happened. We take a multiplied out problem and we're going to factor it out, reverse the distribution, and we're going to make it into a multiplication problem. When we distributed in 3x, we multiplied it in. When we factor it out, we're dividing the 3x out of it. We're factoring it out. So what we have left over, 9 divided by 3 is 3. X squared divided by x is an x, minus 21 divided by 3 is 7, and x divided by x cancels out to 1. 3x times 3x minus 7. That's as far as it goes. Factor completely. I can't take that any further. Once you have x to the first, you're done. That each factor equals 0. This is called the zero product property. If A times B is equal to 0, if you have a product that's equal to 0, then either the A is the 0 or B has to be the 0. The only way you can make 0 is one of them has to be 0. And that's only true if it's 0. It doesn't work if you have A times B equals 6. If you have 6, then it could be 1 times 6, 2 times 3. It could be 3 times 2. It could be 6 times 1. It could be negative 6 times negative 1. It could be 1/2 times 12. There's an infinite number of ways to make 6. But if it's 0, it's either 0 times something or something times 0. One of them has to be 0. So once you have it factored, it's either 3 times x is equal to the 0, or it's 3x minus 7 equals 0. You let each factor equal 0. And that's where you solve. So 3 times x equals 0 divided by 3. 0 over 3.
Yeah.
3 goes into 0, 0 back. And then over here, we add 7. We get 3x equals 7. Divide both sides by 3. 7 over 3. At the bottom of the box on the test, you would just go x equals 0, comma, 7 over 3. If you have the time and you want the peace of mind, plug it into the original question, see if it works. Now, some of you are going to fight me on this. And nobody ever gets it right. That fights me. That's because I just automatically make it one number. You have to show work. You don't show the correct work, you just kind of magically sprinkle dust and all of a sudden you have what you're supposed to have. Well, I take all points because you have to show how you get there. When you're going to factor, or when you're going to do any of the methods, please, you're going to be better off if you keep your square term positive. It's going to be a lot more difficult if I do that problem with negative 2x squared. This is what I'm talking about. We want one side to be 0. So to make 0, I either make the right side 0 or I'm going to make the left side 0. And here's where I see the laziness. It's easier to just subtract 2x squared from this side, from both sides, and they'll have negative 2x squared on this side, 0 on that side, and then you got to contend with the fact that you get a 2x squared. And whether you're factoring, quadratic formula, completing the square, unless you're handling the negative part of that, it's a mess. So the way you fix it, the way you just ignore it or not even worth it. Be careful with it. Bring things to the left. It just means you're going to subtract 19x from both sides, and you're going to subtract 33 from both sides. So you have the first term, 2x squared, minus 19x, minus 33, and then you have your 0. Keep your square term positive, no matter what method you're going to use. You'll be better off. Those that don't, I'll probably do it. Right. So now we're going to solve by factor. First step of factoring, greatest common factor. Do these 3 terms have a coefficient in common? Well, as soon as I see a 2 and that's a 19, they don't have any coefficient in common. Because the only thing you take out of the first term is a 2. The second term is odd. I can't take an even number out of the 19. So they don't have a coefficient. Do they have x's in common? Yes or no? No. No. If they were having x's in common, all of them would have to have an x. This one doesn't have an x, so they have nothing in common. So then we set up parentheses. We're going to factor it. So we need this parentheses times that parentheses, so we can make it equal to 0. And it's a puzzle. We're putting the puzzle together. Think. First times first makes 2x squared. The only way to make a 2x squared would be an x times a 2x. That's the only way. So my first 2 terms have to be x and a 2x. So I know that's right, because there's no other thing that'll work. Then don't worry about the 19. Don't worry about the 33. It's about the sign. You look at the very last sign. This sign times that sign. This one times this one is a negative. Has to be a negative. The only way to make a negative would be a positive times a negative. So it's got to be a positive times a negative. Who knows? I might have to switch them. Maybe it's a negative times a positive. I'll find that out in a minute. But they have to be different. So here's what I know. X times 2x will work. And the signs are right. They have to be different. Everything I've done, if it works, it has to be like this. Then, thing we have to do next will be last times last is 33. So the only way to make 33 is either 1 times 33, always start with 1, and 3 times 11. Make a list. Because if you have something like a 36, which has lots of factors, 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Make a list of all the possible ways because you don't want to miss them. And if you put them out in front of you, maybe you'll see which one it is instead of trying to think of it in your head. It's like a puzzle. You put the pieces on the table face up so you know what you have to do. So, which of those choices do you think has the best chance of making a 19 in the middle? What do you want to try first? Just pick one. This is called educated guessing and checking. Do you think I can make a 19 with a 1 and 33? I don't think so. So let's try 3 and 11. Let's try the 3 and 11. 3 here, 11 there. And what you do next is you check the OI. OI is the middle of FOIL. OI means outside times outside. Plus inside times inside. So outside times outside is negative 11x. Inside is positive 6x. That does not make 19 in the middle. So maybe if I switch it, put the 11 here and the 2 there. Start reading. Outside is negative 3x. Inside is positive 22x. Negative 3 plus 22, negative positive 19x. Ooh, I don't want positive. So here's the deal. I have the right amount, wrong sign. I already know if I switch them, we're going back to the 6. When you have the correct amount of x's or whatever the variable is, don't switch the numbers, switch your sign. When I have the right amount of the middle, just the wrong sign, switch the signs. So we're just going to make this negative, and we'll make this one the positive, because now you get positive 3x, and we get negative 22. 3 minus 22 is my negative 19 in the middle. What makes the first term? What do the signs have to be? What makes the last term? Add them up. Did you make the middle? If you practice, you'll get quicker at it. Solving by factoring is the quickest, simplest, easiest way to solve these quadratics. Now that it's factored, you take each factor, that it equals 0. And you solve. Add 11. This x is equal to 11. Subtract 3. Divide by 2. This x is equal to negative 3 over 2. Down at the bottom of the box, so this is my answers. I get negative 3 over 2, and I get a positive 11. Why should I write my answers in that order? Why is that order a little more organized than putting 11 and then negative 3 over 2. Yeah, from smallest to biggest. Isn't it nice numbers come in some kind of order? (26) Solve the equation by extracting square roots. Okay. This is basically called the square root method. Extracting square roots is not, kind of, I don't think it's clear. Square root method. The square root method is, we want to just take the square root of a perfect square. But you have to remember something when you do this. And it's something that I'll always, keep writing over and over. Before we do this, let me show you something. If we had x squared equals 9, and we don't know anything about square roots, all we know is factor. The rule says you got to make one side 0. So I subtract 9 from both sides. And I get x squared minus 9 equals 0. And then we got to factor this up. It's the difference of two perfect squares. This is x plus 3 times x minus 3 equals 0. So x plus 3 could be the 0. X minus 3 could be the 0. Subtract 3. X is equal to negative 3. Add 3. And take a look. We get two answers, don't we? X is equal to negative 3 and positive 3. So when you have the square root method is going to be take the square root of both sides. What we're after is we want all of the answers, every single possible answer that would solve, that would work, x squared equals 9. And when you take the square root of both sides, if you're not thinking, you're just going to say, oh, 3. You're not going to think about the negative 3. And the question is solve, not simplify. So when we're solving and you take the square root of both sides, your job is to remember to put it's plus or minus a 3. Because positive 3 and negative 3 will both work when you take the square root and you solve it. That's your job to remember. Okay? Because right here, this is how we would normally have to solve it before square roots come out. Okay? The square root method. You have to isolate the constant. So 26. X squared minus 3 equals 78. Method is used to solve an equation with a perfect square and a number. So you just have a perfect square and a number. You don't have an x to the first. So it's a perfect square and a number. X squared minus 3 equals 78.
So you isolate the constant. The constant is the 78 and this 3. So I want to get the constant on that side. So I'm going to add 3. And I get x squared equals what? 81. Take the square root of both sides. Simplify completely. Don't forget the plus and minus. So we take the square root of both sides. The square root of x squared is just x. Equals the square root of 81. Don't forget the plus and minus. Square root of 81 is just 9. Solve for the variable. Simplify both, simplify the answer completely if possible. Can't get any simpler than that. And you're perfectly fine to just write it x equals plus or minus 9. Or you can go x equals negative 9, comma, positive. And list each one. That's just a simple version of square root method. Isolate the constant, take the square root of both sides, simplify completely. Don't forget the plus. Solve, simplify. Another one. 30. X plus 3 squared plus 25. And this is the kind of question I put on the review sheet. This is the kind of question I put on the test. And I'm thinking, all right, this is like a freebie. I hope they remember how to do these because it's a freebie. It's like, here you go, Merry Christmas. Happy New Year. You have a perfect square and just a number. And you know what I'll see people do? They multiply that thing out. And when they multiply it out because they want to use the quadratic formula, they make a mess and they don't remember to FOIL it out. So they took something that was just handed to them, very simple, a nice simple package, and they made a mess out. It's a perfect square and a number. Isolate the number. Subtract 25. So you have your perfect square equal to a number. So undo the perfect square, square root method. Take the square root of both sides. The square root of 2x plus 3 squared is just 2x plus 3 equals plus or minus, take care of that first, and then simplify the square root of negative 25. What is it? 5 what? 5i. So we still have to solve for x. So to solve for x, we subtract 3 from both sides. So 2x equals, can we take 3 away from a 5i? Are they like terms? No. So negative 3 is the real part, and then we have a plus or minus of 5i. And then you divide both sides by 2. Now, here's, because 2 doesn't go into either one of these, this is fine. But if 2 did simplify something, you may want to do this. Divide each one by 2. And then that way you can simplify individual fractions so you don't mess up the simplification. And you're still good, that way you're also going to be writing it as your real plus BI, if your standard form. -3/2 plus or minus 5i over 2. Either way is perfectly acceptable. They're the same thing. This way is a little safer in case it does reduce. Now, when we get to this part on the rest of these, completing the square and quadratic formula. What if it's not a perfect square of a number? What if it's not factorable? See, not every polynomial is going to be factorable. If it doesn't factor, I still have to solve it. So there must be another way. That's when you use completing the square or you use the quadratic formula. That's their purpose, is to solve things that can't be done using factoring. Factoring is the simplest way to do it, but you have to be confident in your factoring. You only got to show me factoring on one problem. All the other ones, you got to show me one way to do, or one problem with completing the square. You got to show me quadratic formula on one problem. The other question, solve it any way you want, as long as I see the algebra. So you better get good at something. So on Monday, we'll continue on with completing the square, quadratic formula, and the rest of the exam. Make sure you have practiced all of your 2.1, 2.3 quick prep. That will be our quiz on Monday. Remember, if you were late, see me so I can mark you late.